All right. We are What Are We Doing? Our project focus on making everyday chores easier. Our problem statement is that people spend too much time on things like laundry, trash, plant care, and security. We designed a solution for everyone who needs extra help, whether that's a busy parent, a senior, a traveler, or even a small business. Our goal is to save time and add convenience and take some of the pressure off daily life.
Cycle mate. This robot essentially um, loads the laundry into the washer. We have a force sensor to detect the um, amount of clothing in the hamper. We have two ultrasonic sensors, one in the front of the robot to detect how far it is from the washer, and another one on the claw to detect how far it is from the clothes. And then um, we have a motor for the arms and the claw, and a motor for the wheels. In this circuit, we have the force sensor on the top left, and then we have the servo motors. One is for the arm, one is for the claw, and then we have two ultrasonic distance sensors, one for the front of the robot, one for the claw. And then on the right, we have our two DC motors, one for the left wheels and one for the right wheels.
And so for surveillance, he's pretty simple. He features a basic design, has a camera, two wheels, and a front sensor and a battery pack. For my circuit features just two motors, one for each wheel, a sensor just to detect any object in front in case it needs to go off track, and then a motor for the camera to rotate 360 degrees.
So rooting for you, there's a plant water robot. It has one ultrasonic sensor, two motor for the wheels, and servo motor for the arms. One ultrasonic sensor, some of the plants, everything start, and it's going to start watering. And servo motor is going to make sure the arm can reach the plant.
Demolisher is this robot. It's supposed to take out the trash for you. So there's a pressure plate at the bottom that when it's full, it'll trigger the cycle and have the robot go to its designated spot, which then will trigger the telescoping plate and dump the trash, and then the robot will return back to its base. In the circuit here, you can also see there's a gas detector. So if there's any like foul odors, it'll trigger the cycle early. And then in the flowchart, you can see all the triggers and processes here. Okay, so for our collaboration here, we have our trash robot and our surveillance robot. The trash robot will stay here until its sensors are actuated. So if the weight sensor tells it the bag is full, or if the gas sensor tells it that it's time for it to go. So that'll go outside to its drop-off area, do its thing, and then it'll come back to home base. Our surveillance robot here is gonna do its patrol in the area and then stay here for 30 seconds, and then it's gonna go on to the next area. Over here, our surveillance robot has shown up in this room. He's gonna do his surveillance again, stay here for about 30 seconds, and then go on to the next room. Our plant robot here is gonna check all of these plants.
So for the value added, most system in the market right now just focus on one robot, whether it's a laundry robot or whether it's a plant water robot. But our system combine all of those, and user can just do it one time and don't have to worry about doing one thing after another. And that's the value we add in the market.
To conclude, this project was really a learning experience. We figured out how to turn ideas into something that works, how to simplify when things got complicated, and how to adjust when things didn't go as planned. If we had more time, we would have improved a few areas like robot communication and early testing. But in the end, we built something we're proud of. It works, it's useful, and it solves a problem that almost every household can relate to.
So this slide shows all of the references we used throughout the course of this project. And then you can also see them in our document file as well.